Welcome back, Year 11 students, and today we're going to be discussing the derivative again, but this time as a limit. Now, what I want you to do is to look at the diagram that you can see. We've actually got, in the red, we've got some curve. Randomly on that curve, we've chosen 2 points, the point at P and the point at Q. Now, point P is the point X, Y. But often we don't call y, we replace it and we say it's x, f of x, because f of x is another way of writing y. And that's why when you look at the graph, you'll see at this point here, at point P, we've gone across x and up y, but instead of writing y, we've called it f of x, because f of x is y. Now, what we've done is we've travelled out a particular distance, and that's h units, which means we're now out at x plus h. So you travel out x, then another h, and you're out at x plus h. So point Q is out x plus h units and up a y value. So point Q is out x plus h and a different y value. I'll call it y2, but I don't know what that is. But instead of calling it y2, I'll say it's x plus h, f of x plus h. That's another way of describing y. So when you look at this particular question now, you can see we've actually got 2 points. Here is our first point. Here is our second point. And if we use those 2 points, and we've got x1, y1, x2, y2, if I use those points in my gradient formula to find the gradient of the line joining P and Q, then I plug it in and end up with f of x plus h minus f of x all over h, because the 2 x's on the bottom, x and the minus x, drop each other out. Now, what I do is I say, well, what actually happens if that h gap, we've gone out x and then we've gone out another h. What if h is a really, really tiny distance, a small, small distance? As a matter of fact, we say, what if h approaches nothing, a gap of nothing? Well, the gradient would still be the same formula, but the h value would be getting really, really tiny. And instead of saying gradient equals, we're going to say f dash x equals. The derivative equals, because the derivative finds the gradient. And that's the process that we're going to go through here. So let's have a look at differentiating from first principles. Before we differentiate from first principles, I'm going to write the formula down. To find the derivative, f dash x equals the limit as h approaches 0, f of x plus h minus f of x over h. That is our formula. So I've got that there now to refer to. When I look at the formula, over here in the question 2 part A, I have f of x, which means that part there I've got. The h, I know, it's just getting close to 0. It's this f of x plus h, which is the new bit. Now, we've done function notation before, so I'm going to come down here and I'm going to say f that has rewritten the question, except you'll notice where I had an x, I didn't put anything. In place of x, I'm now going to write x plus h. X is being replaced with an x plus h, which means f of x plus h equals, now I have to do some expanding of my bracket here, so it's going to be 2 times x, which is 2x, 2 times h plus 2h plus 3. So I pause now. I know what f of x is. I was told that. Question always tells you that. I now know what f of x plus h is. I can use my formula, which I'll go over and use now. So, the formula, and I'll just rewrite it again, it's good practice. The derivative equals the limit as h approaches 0 of f of x plus h minus f of x over h equals the limit as h approaches 0. Now, what do I put in place of f of x plus h? Well, I'd put this in place of it because I know f of x plus h equals 2x plus 2h plus 3. So, I'll go 2x plus 2h plus 3 minus, what do I put in place of f of x? Well, I was told in the question what f of x was equal to. F of x is equal to 2x plus 3. And that's all over h. Now, if I look at the question, I can look in the first bracket on the top, I've got a 2x, and in the second bracket I've got a 2x, and they are being subtracted. So 2x take 2x drops out. If I look at the second bracket, I can see that I've got something else that's going to cancel. I've got a 3, a 3 and a 3. 3 take 3 gives nothing, drops out. Which means all I'm left with now is the limit as h approaches 0 of 2h over h, because everything else is cancelled out. Everything in this second bracket here will always cancel out. If it doesn't, you've made a mistake. So I'm left with 2h over h. Now if I look at 2h over h, I can go, oh, the h's cancel, which leaves me with just the limit as h approaches 0 of 2. Well, notice I kept this limit as h approaches 0 in every single line. Well, now I'm going to get to the end. I'm going to go, well, what if h is, well, it doesn't matter what h is. If h is really tiny, it's not going to matter because I've just got the number 2 there. So I can now ignore the limit as h approaches 0. And that means the derivative of 2x plus 3 is 2. And let's just think about this for a second. If I drew the line y equals 2x plus 3, that's what that is. It's the line y equals 2x plus 3. The gradient equals 2. And the gradient is the derivative, so matches up perfectly. Would have been so much faster just saying what's the gradient. But we're going through this process. This is the way they used to find derivatives hundreds of years ago. We do have much faster ways now, so we're not going to be doing this every single time. We're just going through the process of where the derivative came from originally, and we're just going to do it on a few easier types of questions because it can get very algebraically challenging. Let's look at our second example. I've got f of x. I always need to find f of x plus h. So f of, notice I'm rewriting the question, but wherever there's an x, I'm just putting a bracket. Now, I want to replace every x with an x plus h. And you'll notice that this x was squared, so this bracket, x plus h bracket, has to be squared. Now comes the slightly more challenging part. It's going to be 2 bracket. Now, you can either write x plus h in brackets, x plus h in brackets, and FOIL it all out. I'm going to expand it. Smiley face is what I sometimes refer to it as. If I expand it, x times x is x squared, x times h is xh, but I have to double it, 2xh, h times h squared, plus. Now, I'm going to look at this 5 and times it to x, and I'm going to look at the 5 and times it to h, and that will give me 5x and a plus 5h, take 4. I keep expanding now. I'm going to have to take 2 and multiply it to everything inside that bracket. So I get 2x squared plus 2 2's 4xh plus 2h squared plus 5x plus 5h take 4. Wow, that's quite a mess, isn't it? So, we want to find the derivative. Let's write our formula for finding the derivative. The derivative equals the limit as h approaches 0 of f of x plus h minus f of x over h, which equals the limit as h approaches 0 of, now it's all over h. Let's have a look. I start by putting into the formula f of x plus h. What is f of x plus h? Well, f of x plus h is all of that. So, in a set of brackets, I'll go bracket 2x squared plus 4xh plus 2h squared plus 5x plus 5h take 4, close bracket, minus, oh, should have kept that going a bit further, shouldn't I? Minus f of x. Now f of x was given to us in the question. It's 2x squared plus 5x take 4. So minus, there it is there in the formula, minus f of x. So it's minus 2x squared plus 5x take 4, close bracket. And that's all over h, which equals the limit as h approaches 0 of, now let's have a look. There's a 2x squared, there's a 2x squared, they're being subtracted so they knock each other out. There's a 5x, there's a 5x, they're being subtracted so they knock each other out. There's a minus 4, there's a minus 4, they're being subtracted so they knock each other out. Everything in the second bracket disappeared, which is what I want. Now I continue. What's left over? I have 4xh plus 2h squared plus 5h all over h. Now on the top, I have a common denominator, common factor. I'm going to take out h as a common factor, so I'm looking at the top of the fraction here. H is in every term. So if I take out h as a common factor, I get 4x plus 2h plus 5 all over h. Oh, I can cancel those h's there. And I can go straight to the answer almost now. Now, I'm going to let h actually be 0. It says the limit as h approaches 0. What if h was 0? Well, that h is cancelled, that h is cancelled. I don't have a divided by 0 problem now, so I can actually go to the question and go, well, if h was 0, 2 lots of 0 is 0, that drops out, and all I would have is 4x plus 5. So, if I let h equal 0, the answer is 4x plus 5. And that is what the derivative is, 4x plus 5. So that's the process you need to go through, remember. First of all, find what f of x plus h is, then plug into the formula and follow it through. See how you go. Enjoy.